China and Japan's enduring rivalry, rooted in a history of conflict dating back to the late 19th century, revolves around their competition for influence and resources in the region. This competition often escalates into disputes over territorial claims, historical grievances, and military ambitions. While China has evolved into a global superpower with a robust arsenal of conventional and nuclear weapons, Japan has been actively enhancing its security and international stature. In a recent surprising development, Japan claimed to have successfully tested a unique and highly potent weapon, grabbing China's attention and raising questions about the evolving power dynamics in the Asia-Pacific region. This assertion reflects Japan's determination to reinforce its defense capabilities and assert itself on the global stage, adding a new dimension to the rivalry. The weapon test announcement introduces further complexity to the relationship between these nations, prompting them to reevaluate their strategic interests and engage in more nuanced dialogue. The world is closely monitoring this evolving situation as the interactions between China and Japan continue to influence regional stability and global politics. First, laser railgun test. Japan recently made history by successfully testing the world's first laser railgun, a remarkable development aimed at bolstering its defense capabilities in response to regional security concerns, particularly China's hypersonic missile capabilities. This milestone was achieved as the Japanese Maritime Self-Defense Force collaborated with the Acquisition Technology and Logistics Agency, a division of the Japanese Ministry of Defense. The test was conducted on an offshore platform, showcasing Japan's commitment to advancing cutting-edge technology to counter emerging threats. While specific details about the test, such as its timing and precise outcomes, remain somewhat limited, it is worth noting that this test was groundbreaking in the realm of maritime railgun technology. Traditionally, railguns of this kind are mounted on ships, but Japan's ambitions extend to employing this technology both on land and at sea. This strategic vision represents a significant leap forward and demonstrates Japan's dedication to staying at the forefront of military innovation. According to earlier reports from Shepherd Media, the laser railgun, developed by the Acquisition Technology and Logistics Agency, utilizes an impressive 5 megajoules of charge energy, enabling it to propel projectiles at an astounding velocity of approximately Mach 6.5, which equates to roughly 2,230 meters per second. This technological prowess signifies Japan's commitment to enhancing its defense capabilities and readiness to meet the evolving security challenges in the Asia-Pacific region. Atlas' ambitious plans. The Acquisition Technology and Logistics Agency, ATLA, has ambitious plans to enhance the railgun's capabilities, aiming for an impressive 20 megajoules of charge energy. This announcement was made through ATLA's platform X, previously known as Twitter, showcasing their commitment to pushing the boundaries of this technology. They also shared captivating video footage of the railgun in action, providing a dynamic view of the firing of projectiles from various angles. This display of cutting-edge technology was a remarkable sight, underlining Japan's dedication to staying at the forefront of defense innovation. In addition to the laser railgun project, the Japanese Ministry of Defense, MOD, revealed its decision to develop an electromagnetic weapon system designed to counter the growing threat of hostile hypersonic missiles in early 2022. This decision exemplifies Japan's unwavering commitment to enhancing its defense capabilities in response to emerging threats, particularly in the realm of missile defense. ATLA further stated that they are actively advancing their work on electromagnetic railgun technology. An ATLA spokesperson emphasized their commitment, saying in an interview, Since the financial year 2016, we have studied the underlying technologies of railguns. In these studies, we have focused on increasing launch velocity and establishing material technologies for the rails, ensuring they have high current endurance characteristics. This dedication to research and development underscores Japan's determination to stay ahead in the field of electromagnetic railgun technology, contributing to their overall defense readiness. Electromagnetic railguns. The electromagnetic railgun operates on a fundamental principle. It utilizes electromagnetic force to launch high-velocity projectiles. The device creates a powerful magnetic field between two parallel metal rails, which is harnessed to accelerate a sliding armature carrying the projectile. An essential aspect of the mechanism involves completing an electric circuit between the rails, which are connected to a power source. As current flows through this circuit, it generates a magnetic force that propels the armature and the projectile along the rails. The swiftness of the armature's movement directly correlates with the strength of the magnetic force, ultimately resulting in the launch of the projectile at incredibly high speeds. Compared to conventional guns employing chemical propellants, electromagnetic railguns offer several advantages. These include higher muzzle velocities, longer ranges, lower operational costs, and reduced explosive risks. These benefits make them attractive options for military applications, especially in scenarios where precision, speed, and efficiency are paramount. However, electromagnetic railguns also come with their set of challenges. One major drawback is their high power consumption, which necessitates substantial energy sources to operate effectively. Additionally, these railguns tend to be large in size, which can impact their practicality in certain applications. Another issue faced is rail erosion, where the repeated use of the railgun causes wear and tear on the metal rails, affecting their durability and efficiency. Furthermore, thermal stress is a concern, as the rapid and intense heating during operation can lead to structural integrity issues. Despite these challenges, ongoing research and development efforts aim to overcome these obstacles, paving the way for the continued advancement of electromagnetic railgun technology. Aerial threat defense. Japan has been actively engaged in the development of railgun technology since 2012, with a primary objective of enhancing its point defense capabilities against a broad spectrum of aerial threats, particularly in the maritime domain. This includes countering incoming hypersonic cruise and ballistic missiles. Japan's strategic plan involves mounting railguns on select destroyers and multi-purpose missile defense vessels, which possess improved power-generating capabilities. The Ministry of Defense is committed to the gradual implementation of railguns for early practical use, with the aim of rapidly reinforcing Japan's defense capabilities. Japan's interest in integrating railgun systems with long-range missiles to create a comprehensive defense strategy against aerial threats has been a long-standing aspiration. This strategic move has been on Japan's agenda for some time, and officials have consistently expressed their dedication to developing this cutting-edge technology. Although specific information regarding which ships in Japan's fleet will eventually host these railguns is not readily available, it has been hinted that they may be installed on certain Japan Maritime Self-Defense Force destroyers. This is a crucial step, considering the evolving threat landscape with regional adversaries developing long-range missiles, which puts Japanese destroyers at risk. Furthermore, it has been revealed that ATLA intends to equip several land-based trucks with railguns for engaging hypersonic missiles. This underscores Japan's proactive approach to defense against advanced threats, highlighting the nation's commitment to staying at the forefront of defense technology and its determination to safeguard its security interests. Japan's dedication to railgun technology is not only aimed at enhancing its own defense capabilities, but also at contributing to the stability and security of the Asia-Pacific region. Railgun Interceptors. Japan had a plan to enhance its ballistic missile defense capabilities by incorporating the Aegis Ashore land-based system into its existing arsenal, which included Aegis destroyers and the Patriot Advanced Capability 3 ground-based system. However, in 2020, the Japanese government made the decision to abandon this plan. Instead, the current approach places a strong emphasis on integrating railgun interceptors into the existing missile defense system. This approach is designed to provide a more adaptable and comprehensive solution to address the evolving threat landscape. Under the new strategy, Japan is exploring the use of long-range missiles, allowing them to engage targets from a greater distance. These railgun systems and long-range missiles would work in conjunction, forming a three-tier defense mechanism. This innovative setup aims to mitigate vulnerabilities in Japan's missile response capabilities, enhancing their ability to counter various threats effectively. One notable advantage of railguns is that operators can adjust the speed at which interceptors are fired by controlling the amount of electrical power used. Next-generation railgun system. The next-generation railgun system is anticipated to become operational in the latter half of the 2020s, marking a significant milestone in Japan's defense capabilities. This system is poised to provide Japan with not only long-range missile capabilities, but also multiple interception capabilities. What makes this development particularly remarkable is that, while the U.S. military opted not to pursue electromagnetic railgun technology, Japan has remained steadfast in its efforts. Although there will be a need for several rounds of testing and improved platform integration before the system can be fully incorporated, Tokyo has made substantial progress in this direction, as evident from recent successful tests. The driving force behind this development is the growing concern over hypersonic weapons emerging from regional adversaries like China, North Korea, and Russia. These advanced hypersonic missiles pose a significant challenge to Japan's security, prompting a proactive response. Japanese policymakers are not solely focused on intercepting incoming missiles. They are equally concerned with preventing their launch in the first place. They view this technology as a preventive measure that can send a strong message to potential aggressors. Japan's current plan aims to integrate railgun interceptors into the existing missile defense system. In light of these evolving threats, Japan is actively enhancing its defense capabilities and boosting its military readiness. This includes plans to accelerate the procurement of Tomahawk missiles, which have demonstrated effectiveness in long-range precision strikes. Additionally, Japan is committed to developing its own long-range missile technology, which would offer greater flexibility and control in responding to various security challenges. Hypersonic threats. Japan's growing concerns over North Korea's missile capabilities have been exacerbated as North Korea's arsenal has significantly expanded, including the integration of hypersonic weapons. A stark reminder of this threat occurred just a year ago when North Korea launched a ballistic missile over Japanese territory, landing in the Pacific Ocean to the east. In response to this escalating threat, Japan has been vocal about its commitment to intercepting any North Korean missile that crosses its airspace. The development and integration of railguns into Japan's defense strategy are regarded as a crucial step in enhancing its ability to defend against such threats. Beyond North Korea, Japan faces mounting concerns regarding regional security, particularly in light of China's rapid technological advancements. China claims to have developed heat-seeking hypersonic missiles ahead of the United States. These advanced missiles are specifically designed to target high-value assets, including aircraft carriers and even moving vehicles. This development has further alarmed Japan, prompting a proactive approach to explore advanced defense technologies like railguns to effectively counteract these evolving threats.